Welcome back, folks. Today we're going to continue Chapter 3 and our look at parallel and perpendicular lines along with their properties. In 3.3 deals with proving lines parallel. Our objective is to determine whether two lines are parallel. Now, in the last two lessons, we gave you a lot of different vocab and a lot of different properties for that vocab. The nice thing about this lesson is we're really not introducing anything new. We're just looking at the same stuff from a different perspective. All right, so let's get going with 3.3. We're going to begin things today with the converse of the corresponding angles postulate. Now, in the last lesson, we gave you the corresponding angle postulate. It just said that if a transversal intersects two parallel lines, then we know that corresponding angles are congruent. Today, we're going to look at the converse of that statement. Okay, remember, converse means take the if-then statement and flip the order. Converse of the corresponding angle postulate says if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. Okay, so meaning that if we have a transversal in two lines, and we know that one set of corresponding angles are congruent, such as angles 2 and 6 here, okay, corresponding because they're both on the upper right part of the intersection. So if we know those corresponding angles are congruent, that means these lines have to be parallel to each other. Okay, so what we have here is a way to determine whether or not what we're looking at are parallel lines. So let's go ahead and put that postulate to use. In problem 1, we have a geometric figure with a few different sets of intersecting lines. Now here, notice in this picture, none of the lines are marked as parallel to each other. We don't have any additional sets of arrows on them. It looks like they potentially could be, but we're going to need more information about these different angles to determine whether or not they're parallel. So problem 1 says which lines are parallel if angle 1 is congruent to angle 2. All right, so if we have 1 and 2 congruent, well, let's see what we have. We have then M as a transversal for lines A and B. Lines A and B with M make up those angles 1 and 2. Now 1 and 2 are corresponding angles for lines A and B. And if they're congruent by the corresponding angle postulate, that means that line A has to be parallel to line B. Okay, so again, this picture doesn't tell us anything about parallel lines, but if we have this piece of information, angle 1 is congruent to angle 2, then we know that line A has to be parallel to line B. Same idea with part B, which lines are parallel if angles 6 and 7 are congruent. Well, let's take a look. Here's angle 6, here's angle 7. For angle 6 and 7, we'd have B as the transversal this time, with 6 and 7 being made up from lines M and L. Okay, 6 and 7 are corresponding angles on M and L, and if they're congruent, that means that line L would have to be parallel to line M. All right, so there's an example of using the corresponding angle postulate to determine whether or not lines are parallel. Now, in the last lesson, after we introduced the corresponding angle postulate, we were able to build some other properties or theorems based on that postulate. We'll do the exact same thing here with its converse. We'll start off by looking at the converse of the alternate interior angle theorem. Now, the original alternate interior angle theorem said that if a transversal intersects parallel lines, then alternate interior angles are congruent. Here with the converse, we'll say if two lines on a transversal form alternate interior angles that are congruent, then the two lines are parallel. Okay, so if we have alternate interior angles that are congruent, we know these lines have to be parallel. So really we have another way of determining whether or not lines are parallel. We'll do the same thing with the converse of the same side interior angle theorem. Original same side interior angle theorem said if a transversal intersects parallel lines, then same side interior angles are supplementary. Here we'll say if two lines in a transversal form same side interior angles that are supplementary, then the two lines are parallel. Again, we're just flipping the order of that statement. So if I have same side interior angles, 3 and 6 here, that are supplementary, okay, so add to 180, we again know that lines L and M have to be parallel to each other. And then finally, same idea with the converse of the alternate exterior angle theorem. Original theorem says if a transversal intersects parallel lines, then alternate exterior angles are congruent. Here we'll flip that around. If two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. Okay, so if angles 1 and 7, these alternate exterior angles are congruent to each other, we know that L and M, again, have to be parallel. All right, so let's go ahead and put those theorems or properties to use here. Problem 2 says, what is the value of x for which line A is parallel to line B? Okay, so here we have some expressions for some angles. Okay, so we'll probably have to do some algebra. And we want to know what value of x is going to make these two lines parallel. Now we're going to set these problems up and solve them just like we did in the last lesson. I'm going to say this question we'd answer it the same way as if I said the lines are parallel, find x. Okay, because what we know here is that if these two lines are parallel, we know that these two same side interior angles would need to be supplementary to each other. They'd have to add to 180. So the equation I can set up then is I can say that 2x plus 9, the first angle, all right, plus the second angle, the 111, has to be equal to 180. All right, so this is another one of our angle plus angle questions equals 180. Let's go ahead and solve this equation now. Combine like terms on the left. 9 plus 111 is 120. So we can rewrite the left side as 2x plus 120 is equal to 180. And then we can get the x by itself by subtracting 120 from both sides. I'll cancel out the 120s on the left, giving me a 2x is equal to 60. And then finally divide both sides by 2 to get the x alone, and we end up with x is equal to 30. All right, so when x is 30, that'll make these two same side interior angles supplementary, which means that lines A and B would have to be parallel to each other. Let's take a look at one more algebra problem. 3b says, what's the value of w for which lines C and D are parallel? Again, we'll approach this the same way as if I said C and D are parallel, find w. Now this one's going to work out differently because I don't have same side interior angles again, so these angles won't be supplementary. What I have in this case are expressions for corresponding angles. These are both on the upper left part of the intersection, so I'd say they're corresponding. And we know is that if the corresponding angles are congruent, that's what's going to make these lines parallel. So the equation we'll set up for this one is we'll say that 3w minus 2 has to be equal to the other angle. So it has to be equal to 55. All right, so this is another example of our angle equals angle type of equation. Let's go ahead and solve it quick then. I want to get the w by itself, so I'm going to add 2 to both sides. I'll cancel that minus 2 on the left. We have 3w is equal to 57. And then to get the w alone, we'll divide both sides by 3. And that leaves us with just the w on the left. And my calculator says 57 divided by 3 is a 19. All right, so 19 on the right. All right, so when w equals 19, we'll have congruent corresponding angles, which is going to make lines C and D parallel to each other. All right, so that's it for lesson 3.3. Again, hopefully you're recognizing that we really didn't throw anything new at you. Same vocab, same properties, just taking a different perspective on them and applying them in some different situations. All right, so go ahead and shut the video down, get going on the Math Excel, and we'll see you folks next time.